Okay, so now let's proceed. So now we are starting to understand these things bit by bit. So we are going to question B2 now. So remember, the main question is that we are adding the following numbers in 1's complement using 8 bits, and we determine whether an overflow has occurred or not. So here we are given two similar numbers or same numbers, which is -7 repeating. So what we need to do is that we need to come up with the powers of 2. So first of all, remember we have -77 and -77 itself again. Okay, so by the powers of 2, we said we start at 1. 1 times 2, you have 2. 2 times 2, 4. 4 times 4, 8. 8 times 8. 8 times 2, by the way, 16. 16 times 2, let me just write 16 nicely. We have 32. 32 times 2, we have 64. 64 times 2, we have 128. Okay, so finally we have our powers of 2, which is the 8-bit. By now we understand. So here we have just one number in short. So remember, a negative number is affected by the complement, and in this case we are dealing with the 1's complement. So for us to get 77, we just come at 64. So I'll put a 1 there. So 64 plus 16, it's 80. So we cannot choose that. So 64 plus 8, we have 72. Okay. So 72 plus 4, we have 76. Then plus 1, we have 77. So let's verify. 64 plus 8, 72. Plus 4, 76. Plus 1, 77. Okay, so this is our 77 in binary. Now this is just 77, but we want -77. It's affected by a complement because it's a negative. So here we are saying 1's complement. So 1's complement, as we know by now, is simple. We just flip the numbers. So a 0 becomes a 1, a 1 becomes a 0, and so on. Okay, so there we have it. This is our -77 in 1's complement. So this number is just repeating itself because they are telling us -77 and -77. So I'll just repeat this thing without wasting time. No need to convert again. We've already converted our first -77 in 1's complement. Okay, so remember we're adding, I'll say plus. So focus on the green text. That's what we're adding. So here we say 0 plus 0, we have a 0. 1 plus 1, by now we know it's a 0. We carry a 1. 1 plus 0s, this is a 1. 0 plus 0, 0. 1 plus 1, here we just put a 0 and we carry a 1. 1 plus 1 plus 1. So this is the first time you're encountering this. So let me just explain. So 1 plus 1 plus 1 is the same as having a number which is 3. Okay, now in base 2 is the same as 3 divided by 2. So how many times does 2 enter into 3? It's 1, and the remainder again it's 1. So you can see that here at the bottom we put a remainder which is a 1. So we put a 1 here, but again we are carrying a 1. Okay, so here we carry a 1. So next time we see 1 plus 1 plus 1, just know it's a 1, carry a 1. So 1 plus 0 plus 0, it's a 1. Now 1 plus 1, it's a 0, we know, but this is at the far end. Now what about that 1 we are carrying? Because 1 plus 1, it's 0, carry a 1. Where is the 1 going? So in 1's complement, we don't ignore that carry, but we put it at the bottom. So we put it here. So when we say 1 plus 1, 0, carry a 1, instead of putting it here where there's nothing, we bring it down. Then we continue with our addition. Hope that's clear. If you don't get it now, you understand in the next videos. So 0 plus 1, we have 1. Then the rest are just the same. So there we drag our 0, there 1, our 0, our 0, our 1, and last 3 our 0. Now we need to determine whether an overflow has occurred or not. So what I've said is that what's our bigger number? Here we already know that it's 77. We have just one number. So we started here where we had the first one. So I'll put a demarcation before that. Okay. So this demarcation represents the sign and the magnitude. So the sign, remember, a 0 represents a positive in a binary. Then a 1 represents a negative. So we need to understand what's the outcome for negative 77 and negative 77. So in mathematics, again, we know that we have a negative plus another negative number. So this is the same as plus times negative, we get a negative. So it's negative 77 minus 77. Okay, so when we have two same signs, it's the same as we are adding, then we get that sign. So this is the same as 77 plus 77, but it will be negative answer. Okay, so 7 plus 7, we know that it's 14, so 4 carry 1. Same as plus 7 plus 7, 14 plus 1, we have 15, so 154. So instead of becoming positive 154, the answer will be negative 154. So for us to confirm that truly this thing is correct before even knowing if an overflow has occurred, is that we can try to convert negative 54 into 1's complement. So let's just do that quickly. So here we just say here we have 1, and then 1 times 2, 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 62, times 2, 64, 64 times 2, 128. We have our 8-bit. So here we are trying to make this 154. We convert first 154 in binary. So we know that 128, okay, we will start at 128. So, okay, so it's the same as 128 plus 24. Let's find out, plus 64. Let's find out what can be the answer first. So 8 plus 4 is 12, 2 carry 1. 2 plus 6 is 8, plus 1, 9, then 1. So we have 192, which is far beyond 154. So we skip 64, we come at 32. So what about 128 plus 32? What can be the answer? 128 plus 32. So I'm sure it's 1's key still. So this 8 plus 2, it's 0, carry 1, 5, 6, 1. So 1's key stays beyond 154, we put a 0. Now we come at 16. So now we try out 128 plus 16. So 8 plus 6 is 14, 4 carry 1. And then 2 plus 1, 3 plus that 1 is 4, and that 1 now is just 1. So 144. So this is just okay. So we'll go there. We have a 144. So 144 plus 8, it will be, I'm sure it's 152 now. So let's try. So plus 8. So 4 plus 8 is 2. And then this 4 plus that remainder, which is a 1, so it's 5, 1. So 152. So from 152, we are just meaning with a 2 to have 154. So we put a 1 here where there is a 2. So this is our answer in terms of binary for 154. Now remember, it's negative 154 in 1's complement. So we flip these numbers into a 1, a 0, a 0, a 1 now. So this will become a 0, 1, 1, 0, 0, 1, 0, and 1. So we can verify our answer. So we can see we have 1, 0, 1, 0, 0, 1. So this is 1, 0, 1, 0, 0, 1. Then we have 1, 0 at the far end, which is 1, 0. So we verified that this is correct. Now coming back to the question, do we have an overflow or not? So we were expecting a negative number, but we end up getting a positive number. hence an overflow has occurred. Okay, so let's just confirm. So we master the answer 0 1 1 0 0 1 0 1. Okay, so let's just try to confirm. So now here we can see we have 0 1 1 0 0 1 0 1, and we are saying an overflow has occurred. Okay, so that's it for this video. My name is Asoko James, presenting KMU Cybersecurity Tutorials. I hope you enjoy, and by now I'm sure binary is now making sense. So you can just continue with the playlist for this test 2 until you understand everything. Thank you.